Very good afternoon, ladies and gentlemen. My name is Alin Patran, and I will be your host today. I'm a group manager in Advanced Manufacturing and Technology Center. I have together with me Grace, a team lead in ARTC, as well as Davide, a tech lead. We also have Mr. Goyong, an engineer in the laser metal deposition team. And through the technical support from the Technology Transfer Office, Tom and Peter, we're bringing you live a webinar related to a course which ARTC is proposing, ARTC is conducted, direct deposition 3D printing for manufacturing and remanufacturing. Thank you very much for your interest in this webinar. Let's go quickly through how we are going to present this. We have a number of slides, introduction to the course, going a bit into the content and into why we are doing this. Then there's going to be a Q&A session. Feel free to ask any questions, either by raising your hand or typing in the chat. We will try to answer all the questions as much as possible live. And along the way, if you find a question critical, just post it in the chat and we'll see how to address it either in the end or on the spot. Without further ado, let me pass the ball to Grace.
Okay, thanks, Alin, for the lead in. Hi all, good afternoon. Thanks for joining the session. So my name is Grace, and as introduced by Alin, I'm the team lead of laser metal deposition or direct deposition team here in ARTC. So I'll give a quick introduction firstly to a little bit of our organization, on the concept of advanced manufacturing and remanufacturing, how direct deposition fits into all of these, as well as some applications before passing it on to my colleague, who will describe more about the course that we are offering. Okay, so a quick introduction of myself. So I'm a senior development engineer as well as a team lead at ARTC under A-Star. So I graduated with a bachelor's in aerospace engineering from NTU prior to joining ARTC. So since joining, I've been working on additive manufacturing technologies with a focus, in laser blown powder direct deposition. It is one of the many methods of additive manufacturing. So currently a team lead after 7 to 8 years in this organization. So what we're doing as a team is to drive developments for the technology, towards the next generation of manufacturing, Industry 4.0, which it's really focusing a lot on sustainability and digitalization, as much as developing the manufacturing and remanufacturing solutions for different industry needs. Okay. So before I head into direct deposition, just a quick overview of manufacturing versus remanufacturing, because remanufacturing is a relatively newer term. So a quick sort of slide to describe the key differences between the two. So manufacturing, as you can see, is very much a linear process, starting from extraction of raw materials to refining them and then processing them to parts. And if you have a bigger component with multiple parts as an assembly stage, before it is actually pushed out to the market for use. So at the end of the service life, many of times when you look at the conventional manufacturing process, the components are at the end of its life, once it expires, suffers from damage, cannot be operated anymore. It is put to end of its life, and a large part is usually disposed. However, if you look at remanufacturing, it's heavily focusing on the concept of recycling, trying to save as much energy, materials, as well as cut down on emissions of, for example, pollutants. So in comparison to this linear form of manufacturing, you can already see how remanufacturing is displayed in a cyclic manner. So when you look at remanufacturing, it's really about bringing firstly back the components from service, assessing them to to see whether how much they are damaged, whether they can be repaired, and if they can be repaired, then we do the necessary means, different processes, advanced technologies to repair them. Direct deposition actually being one good method for repair, and I'll explain how later. So after repair, if it's part of an assembly, the parts are put together, reassembled, tested, and put back into service. So in a way, we are saving components that are conventionally sort of disposed. So you can already see a lot of savings that can be achieved. One example over here, it's a study done on mid-sized gas-powered engines. Basically what you can save and how much you can save via remanufacturing compared to typical manufacturing. So three arrows over there, three big pillars: energy, carbon dioxide, and raw materials. And you can, based on this study, the savings are as high as 90%. Okay, so that basically sums up the key difference between manufacturing and remanufacturing. Okay, so now going a little bit into describing ARTC as an organization. So we are a part of A*STAR, and we are the current leading public-private partnership research center in Southeast Asia. So here, I'd just like to point out, that what we aim to do here is really to develop and deploy advanced manufacturing as well as remanufacturing solutions. And one of our goals is also to upskill the workforce to be up to date with all these technologies and skills. And hence, this is one of the reasons we are offering this course, to upskill our local workforce. And ultimately, it's really to drive and empower our local industry to make it more competitive in the global context. So where ARTC sits, it's in between basic or low-level research and industry, because we are constantly developing sort of this mid-level kind of development, where we base a lot of our developments on research knowledge, but at the same time driven by industry needs. So what we develop here can hopefully be accelerated for adoption by industry players. Okay, there's usually a very long lead time and gap between basic research and industry, and we are here to try to accelerate that. Okay, so in the next slide, you can see 6 big technology domains, and these basically are 6 big groups or divisions that ARTC has. So additive manufacturing, industrialization. So this is where the group actually looks into a lot of AM techniques, but focusing on the powder bed methods. The second group, advanced remanufacturing. So this is the group that looks into developing advanced methods for industrial manufacturing and remanufacturing processes. Automation technologies, one of it is masking, which is a highly tedious process, so we're looking to automate that, as well as other similar processes. But the last two is basically the main one that is driving the development of the group, which is machining and regenerative repair, so additive and subtractive towards remanufacturing. So that's the second group, and this is where our team currently sits. Okay, moving on to the third group. So very much going into the next stage of industrialization, is developing advanced robotic solution applications to the level of intelligent robotics applications, where we're moving towards autonomous remanufacturing. Okay, so the next group, data-driven surface enhancement, it's a group that focuses and develops on important and essential pre and post processes that actually would be supporting some of the repair processes that we do, as well as manufacturing processes. So things like shot peening, fatigue enhancement processes, functional coatings, and how do you actually characterize them. So we work very closely with this group as well as others in order to develop a more comprehensive solution for remanufacturing and manufacturing. So for sure, we have to start to inspect the products, the parts, the components. So we have the 5th group that looks into different ways and advanced ways of doing so. So this is a group that looks into for example, NDT techniques, and advanced ways to sort of verify the quality of the parts, which is very important, especially if we look to qualify advanced processes like direct deposition. You want to know how good your deposition is. Internally, is the structure looking good? We rely very much on this group to support us. Lastly, definitely in line with what I mentioned towards Industry 4.0, we have the Smart Manufacturing group that looks at digitalization, life cycle analysis, sustainability. So we are also working closely, and not just on the manufacturing part. Direct deposition has to look towards digitalization as well, in order to keep up with going towards the next state of industry. Okay, so a broad overview of the technologies that we have here, but what I would like to highlight here is there is a very good synergy and support that is required to support the direct deposition in all these different processes. Okay, so a quick basically overview also on the industry customers that we work with. So you can see already it extends across different industry, cross-sectoral. So a lot of the work that we do and the experience and knowledge that we've gained have actually been based on projects done with key members in, for example, transport engineering. You have oil and gas sectors, Halliburton, Shell, IHI, heavy machineries, and then you have aerospace, big players like Rolls-Royce, Siemens and Voestalpine. So these are people that we've done projects with, and through doing these projects, this is where our team here has actually garnered the vast knowledge that that would be applicable for different industries. So at this point, we have more than 80 industry members. Okay. So here, as mentioned earlier, additive manufacturing is a rather broad category that has many different types or methods. So here, what the figure shows is 7 families of additive manufacturing, but if you count, there is 8. Last one is basically hybrid. I'll come to that. So 7 families, I wouldn't go into detail for each of one, and you can already see, I'll point out over here, direct energy deposition being one method, which is really on the powder blown aspect. So some of the others, it's really like binder jetting, binder jet technologies, powder bed fusion. So these are other techniques that are available in AM. So hybrid manufacturing is something that combines additive and subtractive on the same system in the most basic definition of it. So while not a definite or family of AM by itself, but why it's included here is because it introduces an advanced way of performing AM, which is to make things more efficient by combining 2 processes at the same time. Okay. So now just a quick look into the definition of direct deposition, where in its most basic concept, how it works is laser is used as an energy source to melt feedstock material, which can come in either powder or wire forms. At ARTC, we are focusing so far on the use of powder. So this is what our training will be based on. So as mentioned, direct deposition is a method that can be used for repair or even manufacturing. So here it's termed generative and regenerative applications. So there are other names that are linked to direct deposition that you might come across. So even if you have not heard of direct deposition, you may have come across names like laser metal deposition, direct energy deposition. Laser cladding is something that's used heavily in Singapore. Direct laser deposition, another one, and lens. So as you start to read about the technology, you could come across these different names, but they more or less mean the same thing. Okay. Some quick points over here on already why direct deposition and where it comes from. So direct deposition is many a times people associate it with laser welding or welding. So conventionally, when you look to join parts or add material, people look to use welding. And if you think about arc welding, it involves a lot of energy, and there are some disadvantages such as distortion, heat affected zone that you have to contend with However, moving towards the use of laser, laser that direct deposition, another name for it, laser welding, it brings about advantages such as low heat affected zone, a controllable heat distribution, so reducing distortions, offering overall a good and consistent process control, allowing us to achieve possible near net shape geometries, sometimes not even having to machine them. Why? One of the reasons would be the use of laser, which is very fast cooling. So in our training that my colleague will describe later, we will go into detail on how do we better control the laser, go into more detail on why the laser is able to provide all these advantages. Ultimately, through the training, we hope to be able to build your knowledge as well as skill to be able to develop an optimal process for whatever applications that you do. Okay. So lastly, some typical applications for what the technology can achieve for different industries. So you have generative applications. So you fabricate new parts, and usually the systems for powder blown or direct deposition, your systems is very huge compared to, for example, powder bed systems, which have fixed volume enclosures. So it allows us to build large parts. So we call it large format fabrication. So feature addition is another generative application where the technology allows us to create localized features on existing parts. So this brings about economic benefits such as starting with a lower amount of material and being able to deposit features where you only need, rather than machining them from solid blocks, for example. Okay, so repair, as mentioned, is another big area that the technology can enable. So at the same time, we also look into performing coatings and hard facing for wear corrosion resistance, for example. Okay. So that's all I would like to share, and I'll pass the ball back to Alin first to give a lead in for Davide. Alin, back to you.
You're on mute, Alin.
Thank you, Grace. So not really next to me. The second part of the presentation will be dedicated to the actual content of the training, and Dr. Verd is going to present it. So Davide, your stage.
Thank you, Alin. Thank you, Grace, for the introduction. Good afternoon, everybody. My name is Davide. I will introduce this training on direct deposition for manufacturing and remanufacturing. So as trainers for this, in addition to Grace and myself, there will be also our colleague Wo Young, and we'll introduce ourselves now. I'll start first. So my name is Davide. I'm a scientist and technical lead in direct deposition here in RTC since 2017. Before that, I achieved my PhD in material science and engineering back in Spain. And basically, it's almost 10 years, let's say, that I'm working on this technology. Wo Young, want to introduce yourself?
Hello, everyone. So my name is Wo Young. So I'm a development engineer here in ARTC, where my work focuses mostly on direct laser deposition. So I joined in 2019. Before this, I graduated from NTU, a degree in mechanical engineering. And after that, I did an internship with Pratt & Whitney. So over there, I also did work relating to this direct laser deposition. So in total, now I'm about 3 years experience in this topic. All right, thank you. So back to you, Davide.
Thanks, Wo Young. So this course basically is fully developed by us in RTC. It is based on a previous offer that we did to one of our industrial members. And basically, you can see a picture on the bottom right corner of this slide, where it's our team with some of 3 of these trainees and one in front of one of our machines. So we're targeting organization, but even individuals that are looking to have a first understand on this process, but also to develop their capability in this process. For example, you already know some basic knowledges, and basically extend your capability in manufacturing and or manufacturing applications. So the typical candidate for this kind of training is go from, for example, they are technicians or process technician engineer, but can be also interesting for supervisors or even managers. And for example, for quality control, again, managers and engineers. So very broad type of profile, from a more hands-on type of profile to even managing. The training itself will be done in two parts and in two modes, a theory part and a practical part. So there will be this kind of joining the two opportunity. You must learn a bit on some theory to better understand the process itself, the risk, etc. But we think that is important. An important way to understand better processes to have some hands-on, so to touch literally the machine and the process itself. So next, this slide basically is the key learning points that the trainee will bring home. So as even highlighted before by Grace, you will be understanding the fundamentals of the process of laser blown powder direct deposition, understanding not only the process itself, but also, for example, health and safety aspects, licenses that you need to operate the machines, etc. The second one is more on understand the inputs needed for run this particular process. There are a lot of inputs, and how these inputs affect your outputs. So at the end of the training, you will be able to understand how to modify this process, this parameter, what happened to my final product, for example. To do this, for sure you have to understand how to select your input parameters. And for this, for example, you will be able to come out with a systematic strategy to select the process parameters for the direct deposition. And we also describe, it will be also interesting for you to learn how a typical system, direct deposition system, is manufactured in terms of which part is composed by. So we'll go into the system architecture of the direct deposition system. You will learn also on the direct deposition process flow. So what you have to do before the process, during the process itself, and after the process to check, for example, the quality of the part that you manufacture. Finally, I will also go and show you a bit on the process code. So I will describe a bit later on this part, but basically how to teach your machine what you want to do, basically, and how to program your machine and assure that your machine is doing exactly what you meant to do. And finally, also connect to the previous point, is important to understand a bit the quality of your parts. So a post-build evaluation will also be touched during this training. I will give you some understanding on this important part. So the training will be divided in mainly 4 parts that are summarized here in this slide. I will go through each of them now, giving you just a brief introduction again and a bit more of understanding. And please, this one connected to the previous key learning points that I just went through. So the first one is on an introduction on the process. A second one on understanding the technology and the architecture of the machines. A third one on the programming, and the last one on in-process and post-processes activities. So for the first one, introduction to direct deposition, laser powder blown, and safety aspects. In summarizing this in this slide, you can see in the middle is a nozzle. Basically, is the process itself. So there is the laser that is melting the powder that is blown by the nozzle and creating the melt pool on the workpiece, and also flying a bit around. So to achieve this process, what you need are different inputs from a laser, so for sure a laser source. You need feedstock material, as Grace mentioned before, we are using powders in this case. You need gases. Gas is used for carrying the powder into the melt pool and to shield the melt pool itself. So it's, as Grace mentioned before, coming from welding. You need a machine, an operation system, something that you need to key in your program, you need to control the system, etc. So an HMI, for example. You need a nozzle. Here there are pictures two different nozzles. You see there are different geometries, different designs of this nozzle depending on different machines. This one is needed, is a component required to basically deliver the powder exactly where the laser is focused. And as I mentioned before, you need a recipe. So this image on the right side is to highlight that there are a lot of inputs that you need to think about and select to create your process. On the bottom side, there are other two images that are as important as the other. The first one on the left side is regarding the dangers and the risks of the process itself. As an operator or a manager, etc., you must be aware of the risk related to direct deposition and the use of lasers, powders, gases, etc. And on the right side is an extract of a laser license. So in Singapore, you need two types of licenses. We'll go in details also on this point during the training. Both one license to own a laser system and one to operate it. So this is the first chapter, let's say, of this training. The second one is focus understanding of the laser powder blown process and technology. Here in this slide, we report the 4 machines that we have in RTC for different systems from different manufacturers with different characteristics. So during the training, you will be able to touch a bit of each of them, or only one, depends on also on the requirements, maybe from your side and your interest. But if we go through them just quickly now. On the top left corner, we have our through laser cell 7040. It's quite an impressive big machine, I have to say. It's not meant only for laser deposition, but also for cutting and welding. It's a 7-axis CNC machine with two laser units connected to this machine. And there's a peculiar characteristic of a variable, be able to choose a different laser spot size. That is something that's quite unique for this kind of machine. This is a very versatile machine we use for different applications. We somehow modify also a bit of its architecture. On the top right side, we have the beam modulo 400 machine that has the characteristic to be able to run the process in full control atmosphere. So fill the operational chamber with argon and run the process, for example, also for reactive materials such as titanium alloys, for example. On the other side, other characteristics are very similar to the Trumpf machine, except, for example, at the spot size, the laser spot size, for example, is in this case fixed. There are 2 different top peaks, but it's fixed. On the bottom one, we have two machines made by DMG Mori. On the left side, LaserTech 65, and on the right, LaserTech 4300. Both machines are considered hybrid machine. With hybrid machine, in this case, we consider additive and subtractive machine. So in the same system, you have the laser parts for direct deposition and a machining center. So on the 65 is for milling application, and on the 4300 is a bigger machine and is for turning applications. Okay, during the training, basically we'll go through and describe the different parts of the machine, from the laser units, the cells, the chillers, etc., etc. On the third module of this training, we are going to discuss about programming for laser blown technology. We start for the computerized systems, basically that you need, for example, you need to build depositor components that have a complicated geometries. I've reported here two examples. For example, you see the fins on a cylinder. So you need a CAD/CAM software to design this part and to simulate literally the tool path. And the software will give back to you a code that you can input in your machine, and basically you can do the job. However, it's not the only way to have this tool path. So another way, for example, is teaching manually deposition. So using, for example, teach pendants available on the machines, or directly keying your code into the machine itself. It will depend usually on the complexity of the geometries, etc. So a bit of the last part will be on the fundamentals of programming, because it will be important for you to understand what is the software giving you back. So understand what, if there is an issue or a problem, spot it and modify it, and what each line and command needs, for example. Then the last module, the fourth one, is on essential pre-process, in-process, and post-process activities. On the left side of the slide, you can see pre-process. For example, we consider the materials checks, the quality of the machine in terms of the laser quality, the setup itself. So all these parts are very important because affect finally the quality of your work, of your job. In addition, we have some technology that are used in progress. So during the deposition itself, to assure that the quality of the process is fine, and the process is smooth, and there are no issues. So we are going to describe a bit also these possible technologies that will help you to assure that your process is stable. And as I mentioned before, after the deposition itself, you need to check your parts and assure that are okay. And for example, the porosity is low, the microstructure is what you need, the mechanical properties are the one you're looking for. And for this, there are different technologies available in RTC also. We'll go through a bit of them, from 3D scanning, microstructure analysis, mechanical properties, heat treatment, machining. So in the last slide I will present, this is a summary again of the different techniques, technologies, systems that we have here in RTC, and you will be introduced. Some of them you will have a direct hands-on, as I mentioned before. Others are just to understand better how the entire process will works. So for material characterization, additive hybrid processing, so the machine that I described before, toolpath generation. We have 3 different softwares we use here in RTC, in the team, and plus other auxiliary systems that are used, for example, to prepare the powders or heat treatment or cutting samples, etc. With this, I conclude my presentation and I pass back to Alin. Thank you.
Thank you, Davide. Thank you all the trainers for their participation. A few quick words on the admin side. So the course we are presenting is under the Skills Future Singapore umbrella, and it's subsidized for individuals who are willing to attend it because of their interest for qualification or personal qualification. We are going to award a participation certificate. The full price is about $2,800. However, there are subsidies from Skills Future Singapore, depending on your status in Singapore and your age. The registration is on a personal base. This is the requirement for Skills Future Singapore. If it's a company-sponsored event, then the costs will be different. However, we welcome both individual candidates as well as company-sponsored ones. There are some basic requirements for attending this course. However, we are open to discussions, particularly when it comes to company-supported candidates. We want to make sure the course is relevant not just to the candidates, but also to the companies sending them for training. If you can go to the next slide, please, Grace. So this is the end of the formal presentation of the course. Additional information can be obtained through scanning the QR codes. There is a course brochure. There is, of course, a registration link. There is a web page where you can find additional information about the course, as well as if you want to know more about other courses KTO is offering. And with this, we can go to the Q&A session. Let me answer quickly some questions which are already there in the chat. Subtracting mean remanufacturing, right? Not exactly. Let's talk about remanufacturing by talking first about repair. A typical metal part is going to see wear, tear, or damage during operation. So normally, that part can be repaired by adding some material, picture a welding job, and then it will have to be machined, so a subtractive job to be put back in operation. However, remanufacturing is a lot more than just repair. Remanufactured parts are usually offered with a warranted quality at least as good as an original new part. So there is a lot to talk about remanufacturing. Picture it as a very high-end repair, including lots of other processes. There were some questions which I answered in the Q&A directly. So a laser and powder for the two different printing processes, I guess we are talking here about powder bed and powder blown, are used, of course, in different industries for different purposes. Grace already mentioned they can be used for manufacturing new parts as well as repairing or remanufacturing used parts from the field. We will try to touch quite a bit while doing the course into where exactly this parts could come from and how to address the usage for different industry, particularly when it comes to standards. Hey, this module is not $121. No, it's a bit more because there is a bit of GST as well. It's a certificate of attendance, so it's not a certificate of qualification. However, if there is an interest, we can go further and explore qualification at a later stage. Yes, there is a big difference between international participant and Singapore citizen. Singapore citizen, older one, it's even cheaper. Because there is significant subsidy coming from SkillsFuture, and in addition, each Singapore citizen has $500 to use annually for training coming from SkillsFuture. So it's something participants can choose to use those credits coming from SkillsFuture for. Okay, so I guess these are the important questions in the Q&A, but feel free to ask more. Feel free to look deeper. I mean, ask us to look deeper into what this course can bring you, what this course can offer your company or the industry in general, because we are here to try to get this information so you can make a choice eventually with all the information in hand.
Hi, Ellen. While we will have the Q&A, can we have the poll also at the same time?
Oh, yeah, sure. So as our KTO colleagues mentioned, if you could help us with a poll, whether after listening to this webinar, which is live on Facebook and it's going to be available also recorded on Facebook, if you think you already have an idea on whether you will be interested to register for the course or not, just do a quick yes, maybe no click on this one. At the same time, as one of the participants already mentioned, there could be interest in other courses, KTO of ARTC, of additional courses covering quite a wide range of disciplines and technology. So if there is additional interest, just drop us an email, and then we will, or have a look at the website, and from there we'll see how we can help you, how we can help you identify a course which is really of interest and it's suitable for your learning needs at this moment. So as I said, please use this opportunity. You have all the trainers here. You also have the course leader. And whatever questions you may have, just let us know. We'll keep this open for another 4 or 5 minutes. If you find it easier, just answer the question live. I guess the host can allow the participants to unmute, or you can raise your hand. Peter, can you please unmute Husanain? He raised his hand. Peter, Tom?
Hello?
Yes, Husanain, we can hear you.
Hi, how are you? Can you please reconsider the fee for the international participant? Because we would like to join our course, but not to make something moderate.
Sorry, I don't know whether my colleagues now in the institute managed to catch what you said, because I could barely hear you.
No, Lynn was also, we didn't hear from outside either.
Can you hear me now?
Not, I mean, just bits and pieces. One way would be for you to type your question. The other one, if we can't really do it this way, you can drop us an email, any of us, and we can answer in that manner, because we can't hear you properly. I'm really sorry for this.
Hello, how are you?
I'm going to give you my email address in case you have difficulties accessing the documents. So I'll give it to you via chat and just come back to me. Sorry again. Thank you.
Maybe you can type your question either in chat or in the Q&A box.
Okay, so one more attempt to get questions from the participants. Terry, YK, if there is anything you want to clarify now, just let us know, please. Peter, can you please mute Hasanain?
Did another one? I couldn't see the hands.
No, there's no hand. Just mute him because there was background noise coming from his microphone.
Oh, okay.
So one more time, one more attempt. If anybody has any question, you can ask now. You can ask later. Additional materials via the scan QR codes. The materials will be available as recorded. So feel free to reach out to reach to us, and we'll try to answer any question you may have, either for this particular training or for any other trainings the Knowledge Transfer Office offers. And since there doesn't seem to be anything else coming, well, we can close here. Thank you all the participants. Thank you very much. Feel free, as I said, to reach out to us for anything else. Thank you. Big thank you to our colleagues from the KTO